Welcome to Pomodoro Joe for Tuesday, January 31st, 2023. Today we're doing LeetCode problem 1626, best team with no conflicts. This is a medium problem, and as you can see, I've actually already started this one. In fact, I recorded the entire video, but it's way too long because it takes too long to describe and draw out these diagrams. So I'll show you what that means in just a second, but before we get started, I will read this problem statement. You are the manager of a basketball team. For the upcoming tournament, you want to choose a team with the highest overall score. The score of the team is the sum of the scores of all the players on the team. Okay, so far so good. However, the basketball team is not allowed to have conflicts. A conflict exists if a younger player has a strictly higher score than an older player. A conflict does not occur between players of the same age. Given two lists, scores and ages, where scores at I and ages at I represents the score and age of the ith player, return the highest overall score of all possible basketball teams. Okay, this is a tricky one. It's a medium problem, but it's definitely a tricky medium problem. So here are the basics. You're building basketball teams. You want to find the one with the highest possible score, but you have to avoid all conflicts. Now, conflicts occur when you have a player with a younger age and a higher score than another player on the team. So, how do we approach solving this problem? Before I jump in, let's put 25 minutes on the Pomodoro timer, and now we can get started. All right, so every player on our team is represented by two values, a score and an age. Now we can graph these players on a graph where one axis is age and the other axis is score. Given all these players, we can plot them out on this graph. Now, the ranges are not going to be below zero. Everything is above zero. So this center point is not 0, 0. Just imagine you choose the median player, and that's the center point. If you choose any player and put them at the center point, all the other players in the list are going to fall into one of these quadrants. Now, players in quadrant 1, these are players that are younger than our current player and have a higher score. So that will be a conflict. Players in quadrant 2, now they're older, but they also have a higher score, so there's no conflict. Players in quadrant 3, they're older, but they have a lower score, so there's a conflict. And players in quadrant 4 are younger, but with lower scores. So anything below this line, the age line here, those are lower scores. Anything above means they have a higher score. Now, anything to the left of the line means that they are a lower age, they are younger, and anything to the right of the line, of the score line, means that that player is older. Okay, so now that we kind of understand these quadrants, so if we graphed all the players, putting marks, like putting an X where their score and age coordinates are, then you'll find for any given player, you can figure out which players they have conflicts with, because they'll be in that player's quadrant 1 and quadrant 3. And then the players that they're compatible with will be in quadrants 4 and quadrant 2. Unfortunately, while that does reduce our problem set a little bit, that's still an n squared problem. You have to go through every player and compare them to all the other players. So how can we reduce this problem set even further? Rather than graphing all of the players all at once, if we build up our graph over time and we sort the players first, then we can build up the graph from either left to right or top to bottom or bottom to top. It's our choice. I'm going to build this up from bottom to top because that's what makes sense to me. So if we sort all of our players by score, smaller scores to higher scores, then for every player we put on the graph, that player is guaranteed to be the highest scoring player on the graph because we've only graphed players with lower scores. Meaning for that player's quadrants, there will be no players in that player's quadrants 1 or 2 because that player has the top score. There's nobody above them in the scorers. That helps us eliminate basically half the problem set. We don't have to look at any other players and we don't have to worry about quadrant 1 and quadrant 2. So what does that mean in terms of actual code? Well, the first thing we need to do is sort our players. So let's first build our players. Now I'm writing this code for clarity, not for speed. So hopefully this will make sense. It won't necessarily be the fastest, but we'll build up our players. And so for the index, or we can just call it I, in range, the length of our, let's say, scores. It doesn't really matter. Our player will be, we'll make this a tuple, and we'll say their age is first. So we'll say ages at I, and their score is second. So scores at I. So this is our player I. And now we'll just append that player to our players. Now one thing I'm going to do up here is make some helpers. So age will be index 0, and score will be at index 1. Those will come in handy later on. All right, now we want to sort our players. So our sorted players is going to be sorted for our players. And we'll pass in a lambda function to sort. Lambda functions are great for things like sorting keys. Essentially, it will, in this case, it will return a tuple, and x is the element. So we'll sort by score first, and then we'll sort by age second. So now we should have players sorted by the lowest score up to the highest score, and within those ranges, the lowest age up to the highest age. Okay, so now that we have our sorted players, we can get to the real meat of the problem. So now we have to build up some teams. This is where it gets tricky to explain. So we'll essentially go for every player in our sorted players. And we'll say that what is the best team that this player can be on so far? Just looking at the players to the left of this player in the list. Because we've sorted by score, any player that we look at to the left of this player, so any player that came before this player in our list, is guaranteed to have a lower score or equal score to this player, which means that there's no conflict in terms of younger players having higher scores. That can't happen. What could happen, though, is this current player might be younger than one of the earlier players in the list, and this current player does have a higher score than that older player, which will be a conflict. So we need to eliminate the conflicts. So for this player, let's look at all the players that came before and eliminate the ones that can't be on the same team with this player. So we can say well, now we need to have some range. We need to know what players came before. So we need to actually keep track of the starting index. And so we'll call enumerate. This will return the index and the value in this sorted players list. Okay, and so for J, starting at 0, in range up to our index, so that's all the players that came before this player, if that player is older, well, then we have to eliminate them. So let's see. Let's just get the player, or we'll call this teammate. We already have player, so teammate. So the teammate that we're looking at is going to be our sorted player at this index J. Now, if our teammate is older than this player, well, we know they have a lower score because we've sorted by score and they came earlier in the list. So that teammate is older with a lower score. That's going to cause a problem. So that's a conflict. So we'll just continue. We can't use this teammate on our team. Okay, if the teammate is younger, then there's no conflict. They're younger, they have a lower score or possibly equal score, but they can definitely be on our team. So it's tempting to say, oh, we'll have some team and we'll just append that teammate and build up teams this way. But that's a problem. The problem that we run into here is that teammate may have conflicts with players earlier in the list that we don't know about because we're not checking for that. We're only checking for conflicts with the current player. Oh man, so what we'd have to do here is then say, okay, then for every teammate lower than this teammate in the list, let's check for a conflict to make sure that we didn't have any conflict there. That's a lot of work, but wait a second. We've already done that. So this is sort of the key insight. Because we're going through these players already, we're keeping track, we're sort of building these teams. When we run into a player that we want to add to our team, well, that player came earlier in the list, which means that player's already gone through their own team building exercise. So what we really need to do is just say, well, what was the best team that that player was able to create? And we can use that team as our potentially best team. And so instead of adding this teammate, we would just say let's merge that team with my current team. So you just kind of say that teammate built their team up. I think I'd like to be on that team, or I'd like to incorporate that team into my team. How do we do that? Well, this is where something called dynamic programming comes in. We're going to keep track of best teams for player. And it's going to be player at index. So the best team for the player, we'll start that at 0. Or I should say best team score is really what it is. So the best team score for the player is going to be 0s times the length of our sorted players. So this you can think of as sort of a cache to store, well, what's the best team I was able to build for player at index I? Okay, so what we really want to do is when we find out we have a teammate that might fit, we really don't want to append them to some team. We want to say, what is the best score for that player? And that's player at index J. We'll also need to then keep track of our own current best score. Just because player J had a great team doesn't mean that player J plus 1 doesn't have a better team. So we really only want to join the best team. So we'll call it best team score. We'll set it to 0. So our best team score so far will be the max of the best team score or this player's best team. Does that make sense? I feel like this is probably super confusing and I'm not describing this very well. So I hope this makes sense. So as we're going through, we're building up our best teams. Our best team will either be the best team that we've been able to build so far with somebody else's best team, or if this player has an even better team, then we'll incorporate that team as our best team. So once we've found the best team that we can possibly join so far, then our new best score. So now we can say our best team, the best team for player at this current index, I. Well, that's going to be that player's score, because we can add that player's score to the team. So that player score plus the best team score we've been able to find. That's sort of it for we're building up our team. As we get to the best team score we can find so far, we're building up these best team scores for the player and then potentially rolling that team into a future team. When a future player looks back on this player's team, that might be their best team that they can join or merge. All right, and finally we have our result. Well, that's going to be the maximum of all the best team scores. And let's see how well we do. And this should have been players plural. Players. Oh man, so many typos. Okay, finally we passed. All right, I am totally out of time. I'm gonna have to speed through this, but we will submit this one and see how well we do. Okay, not too bad. We beat 73% for runtime. We beat 23% for memory. There are definitely things that you can do to improve on this. I have a lot of helper variables in here. You can use zip to unpack these scores and ages. You can basically streamline this. You don't have to go through and pull out the teammate here. Definite ways to improve this one. I was mostly trying to get this one done in a clear, concise way with an explanation that hopefully makes sense. This one is actually really hard to describe. But if you enjoyed this, I hope you I hope you subscribe, I hope you tell your friends. I hope you go out and write better code.